The silicon diffusion is doped with boron acceptors. The acceptor part is quite important. At a concentration of 2.40 by 1017, this number can be different depending on your problem. To create a diffusion, which is a certain micrometers thick, we're asked what is the sheet resistance for this diffusion. That's important. That's what we're going to find. And then we're given some assumptions that we can use to solve this problem. So to solve this, we're going to look at page 42. And on page 42 is going to be our ND. This is our step 1. So in our step 1, we are going to set our RS to be equal to 1 over our RT. And what is T? Well, T is thickness. And thickness is given to us right here. We have 1.98 micrometers thick. So we have this done, solved. Well, what about this R right here? Well, this R by itself is going to be equal to, and this is something important to remember because we covered this on approximately page 29. And on page 29, it doesn't say, but I'll actually put in the notes right now. So I'm updating it as we're going. It doesn't say then, but it does say now that R is equal to, I think, our sigma, which is equal to a Q in parentheses micro P plus micro N times N. So this is what we have here. So that means R is equal to, let's say our Q is 1.6 times 10 to the negative 19. And now inside of here, let's go on and solve this problem. So what are the things that are given to us? Well, we have our micro P right here. It's going to be 400. I'm going to omit units now just for little simplicity, but there should be units inside of here. We have this 400 right here, so that's going to be our P. Now we need the P. Well, how do we find the P? The P is actually given to us right here. So this is P, and this is because it's acceptors that we can write it as P subscript P. So we have our 400 times 2.40 times 10 to the 17. Now, what else do we have? So we're going to add on to this our N. So we have our micro N and then N. Our micro N is given to us right here as 1,000 times, and then our N, well, we actually have to find that. And looking at page about 29 again, we can solve for this N. So we'll call this as like step 3. And our N, it's going to be an N subscript P is equal to a N subscript I squared over ND. Now our N subscript I squared, this part right here, is equal to this right here. So we're going to plug that in on top, and then we are going to have our ND on the bottom. And our ND is, actually, this shouldn't be an ND. Sorry about that. This should be, for this type of problem, for acceptors, it should be PP. And that is going to be, of course, this right here. So we're going to plug all of that in, and once we plug that in, we are going to get the following as our answer. We are going to get that our NP is equal to 876.042, and this, if you care about units, is in centimeters times the negative 3, or raised to the power of negative 3, or negative cube. So this is our NP. Now, let's look at the next step, because we're not done solving for this yet. This next step, what we have to do is just plug it in. So I'll just write NP here just to save some space. So we're going to plug this in, and now we have everything solved for. We can write that our R is going to be equal to, if we plug all this into a calculator, we plug everything in correctly, we are going to get 15.36 ohms per centimeters for this problem. Now I've omitted units, but I brought it back here, and that's important because R is measured in this, like this. And the reason why this is important is because it's going to take us into our step 3, which is to actually make this micrometers not be micrometers, but to be centimeters. So we know we have 1.98 micrometers. 1 micro is just 10 to the negative 6th. So we're going to have 1.98. And actually, I did that wrong. Should be flipped because the Micros need to cancel out like this, so you're just left with the meters. 1.96, 10 to the power of negative 6 meters. Now we want to put this in centimeters, so we're going to have 1 centi over 10 to the negative 2. This is going to give us 1.96 times 10 to the negative 4, and this is in centimeters. So this is going to be our thickness. And now we can just plug everything in because we have everything. So let's go back here. I'll actually continue doing that in black. So back here, we have RS is equal to 1 divided by, we have our R, which is 15.36. This is ohms per centimeters. And then we also have our thickness, which is 1.96 times 10 to the negative 4, and this is in centimeters. So that's how we would solve it. We're just going to plug everything in. And after we plug everything in, for this question, this specific question with these specific values, we're going to get 328.81, and this is per ohms cubic meters squared.